Hello everyone, and today I'm gonna talk about I'm gonna do a continuation of the last video about union bound, and today I'm gonna talk about the nearest neighbor approximation. Yeah. So the idea about this is that when you have a constellation diagram and you have this signal and this signal and this signal, and you want to find the probability that there is an error, but there are so many ways to calculate it, like the union bound way. There is the nearest neighbor approximation, and what this let's say protocol or method does is that it wants to see only the nearest neighbor. So for example, I'm not gonna see the probability that this one affects my signal or comes here instead of here. I'm just gonna see the nearest ones, which are this one and this one, because they are closer than this one. But in here, I'm assuming that this is a square, so don't get confused. So this distance here is equal to the distance here. And this one, D, is equal to D. And it's literally the minimum distance, D min. Yeah. So if I want to calculate this probability, this error probability, nearest neighbor approximation, as we said, it's an approximation, so we're gonna do this because it's an approximation, and we're gonna do 1 over m sum of m minus 1 I starting from 0 and I, and I'm gonna explain what an I and everything is, and square root of 2 square root of n 0. Well, m is the number of the nearest neighbors, which exactly have the minimum distance. Okay, so I'm not gonna consider this in the equation. I don't care about that. I want the nearest neighbors only. So m is equal to the number of nearest neighbors, and ni is the number of the nearest neighbors, the number of the nearest neighbors. So what I'm gonna do, literally, I'm gonna look at this point, for example, because I'm gonna do the probability of error of everything. So I'm gonna go to this one, and I'm gonna say, oh, how many nearest neighbors does he have? Oh, it has 1 and 2. So the number of the nearest neighbors is 2. And I keep on doing that, iterating it for this one and this one and this one and this one, and I sum them up, and then I have to divide them, obviously. So I have to calculate this one plus 1 plus 1 plus 1. So big M is the number of all of them, and Ni is the number of the nearest neighbors, considering with respect to only one when I'm doing this. And for example, on this one, this is the QPSK quadrature phase shift kink, and we have 4, so PE is equal to 1 over 4 sum of 3, 0, I is equal to 0 starting from I, and I, and Q D minimum over square root of 2 and 0. And I keep on doing this. For 1, I is equal to 1 and 2, so that's 2. And it's gonna be in the end of the line, it's gonna be, and since it's a square, so D minimum is the same D minimum, so Ni is gonna be 2 Q D min over square root of 2 and 0 plus same thing plus 2 Q D min over square root of 2 and 0. and at the end of the line, I'm gonna end up, how many times I'm gonna do this? I'm gonna do this 4 times. So 4 times 2, that's 8 over 4, that's 8 over 4 q d min over square root 2 of n 0 to q d min over n 0. And you will get this in when you do this in a problem or an exam. D min is always given. And yeah, that is the end of it. Completely simple, completely doable. And the next video, I will talk about the difference between nearest neighbor approximation and union bound. Please like and share this video, and let me know if this video is helping you or not.